Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O-Levels Physics 5054. In this video, we are going to present you the solution of the October-November 2024 2-1 paper. This is a paper 2, and this belongs from the variant 1 or you can say zone 1. The time allowed in this paper is 1 hour and 45 minutes. The total marks for this paper are 80. I want to give credit to the Cambridge Assessment International Education. This paper which I am using and the marking scheme which I am using is their property. I have just downloaded this paper and the marking scheme from their website, and I am just using it. The creator of this paper and the marking scheme is Cambridge Assessment International Education. I have only written the solution of this paper, and I'm going to describe and I'm going to explain the solution of this paper. So all the credit is to the CAIE. So let's start today's paper, and here we go. The time allowed is 1 hour 45 minutes. So let's start today's paper. The value of the G in this paper you will take as 9.8 meter per second square or 9.8 Newton per kg. So here we go. The first question is coming up on your screen. So the question number 1 is showing up. It says a trolley of mass 0.20 kg is at rest on a frictionless surface. A block of wood is attached to the trolley. The volume of the block of the wood is 0.0012 meter cube, and the density of the wood is 650 kg per meter cube. Calculate the combined mass of the trolley and the block. The mass of the trolley we already know. The mass of the block we don't know, but we know the volume of the wood. We know the density of the wood. So first of all, I can find out the mass of that wood. So the mass is equals to the density multiply the volume. Once you know the mass of the block, then add it with the mass of the trolley, and you will be able to find out the total mass. So here we go. The density is equals to the mass divided by volume. Density is 650 kg per meter cube, and the volume is 0.012. So the mass will be equals to 650 multiplied 0.012, and the answer you will get is 0.78 kg. Then add the mass of the trolley and the mass of the wood. 0.78 kg plus 0.2 kg, and that will be 0.98 kg. So we think the answer is 0.98 kg. So our answer is right. So let's go to the next part. This is question number 1, and it's B part. And figure 1.1 shows that a student attaches a spring constant 14 Newton per meter to the front of the trolley. So here you have a spring which is attached with the front of the trolley. Here is the wooden block. Here is that trolley. This surface is frictionless. Okay, the student holds the trolley and block and stretches the spring. He releases the trolley and block. The trolley and the block accelerates from the rest. As the trolley and block accelerates, the student keeps the extension of the spring at 0.035 meter. Calculate. The question is calculate the force exerted by the spring on the trolley. So we know the extension and we know the spring's constant. So we can find out the force which is exerted on the trolley. You know, F is equals to Kx. F is equals to Kx, where K is the spring's constant and X is the extension. And very easily we can find that force. So you know F is equals to Kx. So the F is 14 and the extension is 0.035 meter. And when you multiply 14 with the 0.035, you get 0.49. So the force is 0.49 Newton. So you can see 0.49 Newton. Our answer is right. Okay. Then he says the trolley and block are pulled a distance of 0.86 meter by the spring. Calculate the work done on the trolley. Because the surface is frictionless, the force which we have applied is the resultant force because there is no friction. So the work done is equal to the force multiplied the distance traveled in the direction of the force. So we know the force, which is 0.49 Newton, and we know the distance traveled by the trolley, that is 0.86 meters. You simply multiply them, you will get the work done. So 0.4214 is the answer. When you round it off, it is almost 0.42 joules. 0.42 joule is the right answer, sir. So here, and he says, explain why the power transfer to the trolley and the block increases as the speed increases. Explain why the power transfer to the trolley and the block increases as the speed increases. Okay. So, see, the work done is the force and the distance. Okay. And the power is the work done divided by time. So when the trolley will speed up, so that trolley will cover the distance in less time because the trolley is moving faster. So the power, which is work divided by time. So if the trolley starts covering the same distance in less time, so the work done will be done in the less time. So that's why the power will increase. This is my thinking. So let's see. This answer, we have written distance moved by the trolley per unit time increases as the speed increases because the power is equal to the work done divided by time. The work done in unit time increases. Work done means in 1 second, the work done will be more because the trolley will be covering more and more distance in unit time. So the power, which is work divided by time, because to do the same work, now it's taking less time. Or you can, in other words, say in the unit time, now you are doing more work because you are covering more distance in the unit time. So that's why the power will be larger. So this is what we think. And he says that 1 mark is for saying that the distance moved, work done in 1 second unit time, a given time increases as the speed increases. The work done in 1 second, that's unit time increases. So this is the marking scheme. Our answer is I hope that you understand this. Okay, so we are going to the next question. The next question coming up on your screen is question number 2, and it says, a student makes a ball from modeling clay. The ball has a mass of 0.20 kg. She drops the ball from a height of 40 meters above the ground. Calculate the initial gravitational potential energy of the ball. You know the gravitational potential energy. Its formula is mgh, where m is the mass taken in kg, and g is the gravitational field strength, which is 9.8 Newton per kg, and h is the vertical height. So write this formula first of all, and then just enter the values. You will be able to find out the solution. So the gravitational potential energy is equals to mgh, 0.2 kg multiply 9.8 Newton per kg multiply 40 meter. So you will get 78.4 joule. 78.4 joule is the answer. That is question number 2. So let's check. So we are on the question number 2. And the marking scheme is showing up on your screen, and you can see the answer is right. Okay. So here we go. We are done with the question number 2A part, first portion. Calculate the speed of the ball immediately before the ball hits the ground. You see, when you are coming from the top to the lower level, the loss in the gravitational potential energy will be equal to the gain in the kinetic energy. Loss in the gravitational potential energy will be equal to the gain in the kinetic energy. The loss in the potential energy will be 78 joules, which we just calculated. That whole energy will be converted into kinetic energy. So when it's about to hit the ground, the kinetic energy will be 1 by 2 mv square. We know the mass. We know that it will be equal to 78 joules. So 78 is equal to 1 by 2 into 0.2 into v square. The kinetic energy formula is 1 by 2 mv square. So when you take 2 to the other side, you take 0.2 to the other side. So 78 multiplied 2 divided by 0.2, that will be 20, and that will be something, and then you take the square root on it on both the sides, so that will be 27.9. But after taking the square root, the answer will be 27.9, which is approximately 28, which is approximately 28 a meter per second. So we think that the answer is 28 a meter per second. You can have a look at the marking scheme. I hope you understand this. And this is how we have done, my student. This solution is written by one of my students. Her name is Hajra. We are very thankful to her for writing this solution, and but because she is a student of 11 Camry right now, so she sometimes misses some steps, but courtesy, that's due to her that we have this solution. She has written the solution in our supervision, but still she misses some steps. You are supposed to write each and every step. That will be very good for you. Okay, now we have the question number 2. It's B part. He says, when the ball hits the ground, it stops moving. The kinetic energy of the ball is transferred to the internal energy. The temperature of the ball increases. The specific heat capacity of the modeling clay is 1400 joule per kg per degree centigrade. Calculate the maximum possible temperature increase of the ball. Show your working. So it's very simple. You see, we know that the heat is equals to mc delta theta. Heat is equal to mc delta theta. Whenever there is a change in the temperature, we use this formula. Heat is equal to mc delta theta, where m means the mass of that thing and the c means the specific heat capacity of that thing, and delta theta means the change in the temperature. So and heat means the heat which you provided, the kinetic energy will be converted into the thermal energy. So we can apply that formula and we can find out the change in the temperature. Let me show you. So heat is equals to mc delta theta. Heat which you provided is that kinetic energy which converted into the internal energy. 78 is equal to 0.2 multiply 1400 multiply delta theta. Delta theta means the change in the temperature. So delta theta will be equals to 78 divided by 0.2 divided by 1400. When you enter these values in your calculator, you will get 0.278. So there will be a change of the temperature of 0.28 degrees. 0.28 degrees change of the temperature will take place. So this is how we have done this part. Okay. So question number 2B, and it's the second portion, and it says, suggest one reason why the actual temperature increase of the ball may be smaller than the value calculated in the first part. You see, not all the energy used to increase the internal energy of the ball. And some of the energy is also transferred to the ground. Some of the energy used to increase the temperature of the ground. Some of the energy used to produce the sound. Some of the energy used to create a dent in the ground. So not all the energy is converted to the internal energy of the ball and used to increase the temperature of the ball. It's a 1 mark question. Due to air resistance, kinetic energy is less than. Oh yeah, that one very important thing in actual case, there will be air resistance. So some of your kinetic energy will be used to overcome that air resistance as well. Due to air resistance, kinetic energy is less than the calculated value. Also, some thermal energy is absorbed or transferred to the ground. So these are some suggestions which we are providing. Some thermal energy transferred to the ground, or work is done deforming or modeling clay. The clays, yes, thermal energy will be also used to deform the clay. Air resistance work done means that speed, kinetic energy less than the calculated value. So I hope you will be able to write. It's not necessary that you write these answers which we have written. We are showing you the marking scheme. We are telling you the concept. So you can write it yourself as well. Okay, so my dear students, we are on the question number 3. Figure 3.1 shows gas at room temperature. The gas is trapped in a metal cylinder by a metal piston fixed in position. The important thing is he says fixed in position, so it's not moving. So the volume is not changing. The metal cylinder is immersed in the boiling water and the temperature of the trapped gas increases. You see the volume is constant and the temperature of that gas is increasing. Explained in terms of electrons and the atoms of the metal, how the thermal energy is transferred through the walls of the metal cylinder. You see the metal cylinder which you have put in the hot water. Now the energy is transferred from that hot water and through the walls of that container to the gas which is inside those containers. So how do that energy has transferred through those metal walls? You see, metal is solid and those walls are solid. So what will happen? The molecules which are at the hot end, they will absorb the energy, they will start vibrating vigorously, and their amplitude of their vibration will increase. When the amplitude of their vibration will increase, what will happen? They will collide with their neighboring molecules and or particles, you can say, and they will make them vibrate vigorously in their fixed position. So the amplitude of their vibration will also increase. In this way, through the vibrations of the atoms, the energy is transferred from the hot end to the cold end. Another very important way, another very important way is that the energy is transferred by the free electrons because the metal has free electrons. So the electrons which are at the free at the hot end, they will absorb the energy and they will flow towards the end which is cold, and those electrons will go there and they will collide with the atoms there and they will make them vibrate vigorously. In this way, through the free electron diffusion, the energy will be transferred from the hot end of the metal to the cold end of the metal. It's a 3 marks question. I hope that you will be able to write this answer. So let's see, here we go. Hajra has also written an answer. So let's check her answer. Through conduction and free electron diffusion, she's saying that the energy is transferred through that metal by the conduction and by the free electron diffusion. Atoms at the hotter end vibrate and collide with the electrons. Electrons move through the metal and transfer energy by colliding with the distant atoms. So you can say here she has not written a very good answer. So you should write that the atoms vibrate and the amplitude of their vibration increases, and this happens, and they transfer the energy through their vibration to their neighboring molecules and make them vibrate vigorously, and their amplitude of vibration increases, and this way by the vibration of the atoms, energy is transferred. And other way of transfer of energy is free electrons. The free electrons which are at the hot end, they will absorb the energy and they will move, they will flow, they will go to the cold end, and there they will collide with the atoms. And when they collide with those atoms at the cold end, they will make them vibrate. So these are two methods which are happening and they are causing conduction. This is the way the conduction happens in a metal. So I hope you understand. So let's check the answer. What the marking scheme says, you are supposed to write your own answer. Vibrating atom particles ignore electrons, collide with electrons. Electrons move a long distance through the metal. Moving electrons collide, interact with the distant atoms. Ignore electrons. Electrons carry energy through metal. So vibrating atom particles, atoms collide with electrons. Okay, electrons move a long distance through metal. 1 mark for this. Moving electrons collide, interact with the distant atoms. Okay, so this is a 3 marks question. I hope the marking scheme is in front of you. This is one of my students' answer, but I am saying this answer is not of that level. It has some deficiency. So write a good answer, and here we go. That was a 3 marks question. So question number 3 is B part. He says the piston is fixed in position, so the pressure of the gas increases as the temperature of the gas increases. State what happens to the motion of the particles of the gas as the temperature increases. You see the temperature it depends upon the speed of the particles of that thing. So when you increase the temperature, basically what happens, we're talking about the gas. So the gas molecule starts moving faster. So when they move faster, their average kinetic energy increase. That's why the temperature will increase. So when the temperature is increasing, the kinetic energy of those particles is increasing, and those particles are now moving faster. So let's check what Hajra has written. The particle speed increases, they move faster. This is what she has written. So let's check the answer. Their particle average speed increases. So this is the marking scheme's answer. Okay, then question number 3B and its second part. Explain in terms of the particles of the gas why the pressure the gas exerts on the wall of the metal cylinder increases as the temperature increases. So you see, in this case, the volume is constant. You are increasing the temperature. So the temperature and the pressure when the volume is constant, they are directly proportional to each other. So what happens when you increase the temperature? The particles of the gas starts moving faster. Their collision frequency with the walls of the container increases, and they exert more because they are moving faster. So now they will be exerting more force on the walls of the container because they have higher kinetic energy. So they are hitting the walls harder. So two things are happening. Their collision frequency has increased with the walls of the container, and the force they are exerting on the walls of the container has also increased. That's why the force per unit area exerted by the force on the walls of the container has increased. So the pressure of the gas has increased. Let's see what my student has written. She has written the kinetic energy of the particles increases. They collide with the walls of the container with more force, more frequently. Area remains constant and the pressure force, so the pressure increases. Force per unit area has increased. That's why now here you see you can write that the collision frequency of the gas particles with the walls of the container increases. The gas particles hit harder. They exert more force when they collide with the walls of the container. So that's why the pressure of the gas will increase because now more force per unit area is being exerted. So have a look at the marking scheme. It says particles collide with each other in the walls of the container. The particles exert greater impulse or greater force. Collide more often, harder with the walls of the cylinder. So these are the three marks, and this is what she has written. I have also added some words in it, and you can write a good answer. Okay, question number 3C part. The gas in the cylinder reaches a temperature of 100 degrees centigrade. The piston is released and moved to the right. The temperature remains at 100 degrees centigrade. The pressure of the gas now decreases. Explain in terms of the particles of the gas why the pressure of the gas now decreases. You see, now they have kept the temperature constant and they have changed the volume. They have increased the volume. Now the pressure will decrease. If the temperature of the gas is constant and you increase the volume of the gas, the pressure will decrease because the pressure and the volume, they are inversely proportional to each other. If the temperature of the gas is constant and you increase the volume of the gas, the pressure of the gas will decrease. Okay, their question is plain in terms of the particles of gas, why the pressure of gas now decreases. Because if you keep the temperature of the gas constant and increase the volume, the collision frequency of the gas molecules with the walls of the container increases. The collision frequency of the gas particles with the walls of the container decreases. That's why, what will happen? The pressure of the gas will decrease. Don't say that now they are hitting less harder. So particles move away from each other, volume of the gas increases, less collision per unit time. Okay, this is my student's answer. So let's check from the marking scheme what the marking scheme says. Marking scheme says particles are further apart, so fewer collisions in unit time, less frequent collisions, longer time between the collisions. So my answer was that the particles now they have less collision frequency with the walls of the container. That's why a less force is being exerted per unit area. So then we have eventually, he says question number 3C, And its second part, he says, eventually the piston starts moving. Explain why. You know, the internal pressure of the gas, and outside we have atmospheric pressure. So the atmospheric pressure is outside. So it's trying to push that piston inside, and the gas which is inside, that is trying to push that piston out. So when the inside pressure is more, it exerts there is a resultant force in the outward direction, so that piston moves. And as the piston moves, the volume increases and the pressure of the gas decreases. At some time, what will happen? The pressure of the gas which is inside that cylinder, that will become equal to the pressure of the atmosphere. When the pressure of the gas in the container and the atmosphere pressure outside the container, they become equal to each other. The force exerted from outside towards inward, and the force which is exerted from the gas pressure inside, outward force, they become equals to each other, and the resultant force becomes zero, and the piston stops moving. When the gas pressure in becomes equals to the atmospheric pressure, the piston will stop moving because the resultant force will become zero. This is a 2 marks question. So let's see what Hajra has written. Eventually, the piston starts moving. Explain why. Pressure of the gas becomes equal to the atmospheric pressure. Therefore, there is no resultant force on the piston. So let's check from the marking scheme. What does the marking scheme says? Pressure becomes equal to the atmospheric pressure. 1 mark for saying this. And no resultant force on the piston. Force to the left equals force to the right. Air resistance friction between piston and the cylinder was mentioned. So the outward force and inward force, they become equal to each other. The piston stops moving. Okay, my dear students, question number 4 on your screen. A student directs a beam of white light from a filament lamp towards a glass prism in a dark room. Figure 4.1 shows the beam of white light incident on the left-hand side of the glass prism. A screen is placed to the right of the glass prism. Red light is observed at the point R on the screen, and the violet light is observed at the point V. Draw on the figure 4.1 to show the paths of the red light and the violet light between the left-hand side of the prism and the screen at the point R. You see, one thing is very important. You see, when the light will enter here, when the light will enter, the light will bend towards the normal because the prism is a denser medium. So, and when the light here will exit, the light will split, the light will bend away from the normal. So you see what will happen. So what will happen then? When the light enters into the prism, the light will split into its color. At this point, when the light will enter into the prism, the light will split into its colors. And when it will come out, it's still splitted. And it is supposed to bend towards the normal. Let me show you. Okay. One very important thing. You see this line? The lines must be below this line. Okay. So this is how you draw this line. So at this very point where it enters into that prism, the light splits into its colors. And when it comes out, it bends a little more towards the bottom. Okay. Then their question is, state what these observations about the region in the speed of the red light and the change in the speed of the violet light as each enters in the glass from the air. You see the red light has bended less and the violet light has bended more. So when the light basically enters into the glass, its speed slows down, its speed decreases. It means the change in the speed of the red is less. The red is relatively faster as compared to the violet. Both light travels more slowly in glass than the air. Red moves faster than the violet in the glass, so it bends less. Red is bending less, and the violet is bending more. It means the speed of the violet is slow, more slow as compared to the speed of the red. Basically, both speed has decreased, but there is a more drop in the speed of the violet. So let's have a look at the marking scheme. At least one ray from left hand side showing correct refraction of both faces and no incorrect rays. At least two correct rays, two rays within the glass and one ending at R and the other at the V. Both red and the violet light travels more slowly in the glass than in air. Red light travels more quickly than the violet light in the glass. Okay. So hopefully the marking scheme is showing up in front of you so you can write a good answer. So let's move to the next one. Then he says five other colors of the light appears on the screen between the red and the point at the point R and the violet light at the point V. State the names of the five colors and list them in the correct order from the red to the violet. You remember, we say Roy G. Biv, red Roy, R-O-Y G. Biv, and that is red, orange, yellow, green, blue, indigo, violet. The code, the mnemonic by which we remember this is Roy G. Biv. Roy G. Biv. R-O-Y-G-B-I-V-E. Roy G. Biv. So red, orange, yellow, green, blue, indigo, and violet. Roy G. Biv. Okay. Then they say state how the frequency, the question is, state how the frequency and the wavelength of the colored light changes going from red light to violet light. As you go from the red to the violet, the wavelength decreases, frequency increases. So first of all, he's talking about the frequency. As you go from the red towards the violet, the frequency will increase. The violet will have the more frequency as compared to the red. And the wavelength, that decreases. So the violet will have less wavelength, the red will have more wavelength. So the frequency increases and the wavelength will decrease. Okay. So this is the marking scheme. Let me show you. Okay. Okay, then he says on the figure 4.1 point P is shown immediately next to the point R. No light is observed at the point P, but a detector at the point P registers radiation reaching the detector. State which region of the electromagnetic spectrum is detected. So this is from red to violet is the visible light. And above the visible light at the point P, this is infrared, which is not visible to the naked eye. So that's infrared, and infrared is the answer, sir. So this is how you do question number 4. I hope you understand. Okay, so we are going to the next question. That is question number 5. He says ultrasound is a longitudinal wave which cannot be heard by humans as the frequency of the ultrasound is too high. Ultrasound waves cannot travel in a vacuum. Explain why. You see, the ultrasounds, they are mechanical waves. They are like sound waves. And they travel in a medium through the vibration of the particles of that medium. When there is no medium present, so the energy cannot be transferred. So the ultrasounds need medium. They are mechanical waves. They require vibration of the particles to travel. They need medium to travel. In vacuum, there are no particles. So the longitudinal waves, they will not be able to travel. Look at the marking scheme. The marking scheme says ultrasound is transmitted by vibrating matter or the particles. No matter particles in a vacuum, no medium. So they will travel in the vacuum. So question number 5 is B part. He says, describe how a longitudinal waves differ from a transverse wave? Listen carefully, this is very important sentences. You see, in the longitudinal wave, the particles of the medium vibrate parallel to the direction of the wave. In transverse waves, the particles of the medium vibrate perpendicular to the direction of the wave. This is one difference. The other difference is that in the longitudinal waves, they consist of compressions and rarefactions. Whereas the transverse wave, they consist of crusts and troughs. So let's see. Ajra has also written some differences. Particles of the medium vibrate parallel to the direction of the motion of the wave in longitudinal waves. In transverse waves, the particles of the medium vibrate perpendicular to the direction of the motion of the wave. He says in a longitudinal wave vibration, the particle is parallel to the propagation direction. In a transverse wave vibration, the particle is perpendicular to the propagation direction. Hope you understand. Let's go to the next part. Question number 5 is C part. He says an ultrasound transmitter used for a medical scan produces an ultrasound wave of the frequency 8.4 megahertz. In soft human tissues, ultrasound travels at 1500 meters per second. Calculate the wavelength of this ultrasound wave in soft human tissue. You know, we know the velocity of that sound. We know the frequency, that's 8.4 megahertz. And we want to find out the wavelength. You know the equation of the wave, V equals to F lambda. V equals to F lambda. So we can find the lambda. Lambda represents the wavelength. So here we go. V equals to F lambda. So V divided by the F will be equals to the lambda. The frequency is 8.4 megahertz, which means 8.4 x power 6. So 1500 divided by 8.4 x power 6, and the answer will be 1.785 into 10 to the power minus 4, 1.8 x power minus 4 meter. 1.8 x power minus 4 meter is the wave length. I hope you understand. This is how this is done. Okay, then he says the ultrasound waves passes from the soft tissue into bone, where the speed of the ultrasound wave is greater than 1500 meters per second. State what happens to the frequency and to the wavelength of the ultrasound as it passes into the bone. You see, because we are talking about the sound waves, their behavior is little different than the light waves. You know, they are talking about the frequency used when the waves went from one medium into another medium. The frequency do not change. The frequency remains unchanged. But as you know, the speed of the sound waves is greater in the bone. So whatever happens with the speed, same thing will happen with the wavelength. So the wavelength will also increase, but the frequency will remain unchanged. So the frequency remains unchanged and the wavelength will increase. So that was question number 5. So on your screen, question number 6 is showing up. A bar magnet can rotate freely around a thin rod through its center. The bar magnet is at rest on a frictionless horizontal surface in a laboratory, which is shielded from the Earth's magnetic field. State a substance from which the bar magnet could be made. The bar magnets, the permanent magnets, are normally made by steel, from a material which is called steel. This is the most famous material of which the bar magnets are made. So our famous answer, steel. So have a look at the marking scheme. Question number 6 we are doing here. Okay, then he says, question number 6 is B part. He says, the thin rod is perpendicular to the top and bottom surface of the thin rod is, okay. Okay. So this thin rod is like a pivot, okay? The thin rod is perpendicular to the top and the bottom surface of the bar magnet. Figure 6.1 shows a view from above. It's like this. This is a thin rod. Here is the bar magnet, so it's able to rotate freely. So it's like the pointer of a compass. Huh? Surface of the bar magnet. Figure 6.1 shows a view from above of the bar magnet with the north pole and the south pole and the thin rod label. Okay, they draw on the figure 6.1 to show the pattern and direction of the magnetic field around the bar magnet. You see, the magnetic field always starts from the north, they come out and they go and they enter into the south. From here, north, they come out and they enter into this south pole. So it's very simple. So you will draw the magnetic field pattern and they all should be coming out of this north and then they go around in the air and they enter into the south pole of that bar magnet. So this is how you will draw that pattern. At least two complete field lines on each side of the magnet and at least one field line on each side that begins and ends on short side corner of the magnet and all lines drawn of the correct shape. At least one arrowhead from north to south and no arrowheads wrong. Okay, so just draw like this. Okay. Then we have question number, I think 6 is C part. It says, an electromagnet is switched on and the strong magnetic field is created around the bar magnet. The figure 6.2 shows the direction of the strong magnetic field due to the electromagnet is from left to right across the page. So these lines are basically representing the magnetic field which is produced by that electromagnet. And here is your bar magnet pivoted on this thin rod. Draw arrow on the figure 6.2 to show the direction of the horizontal forces that act on the poles of the bar magnet. You see, this north will experience a force along the direction of the magnetic line. So the force created here on the north that due to these magnetic lines will be towards the right, and the force exerted on this south will be towards the left. South pole of this bar magnet will experience a force opposite to the magnetic lines, and the north will be experiencing a force which will be uh, parallel to the magnetic lines in that area. So let me show you. So here the force will be in this direction, and here the force will be in this direction. It says one arrow at each pole in opposite directions or one arrow at each pole parallel to the field line. One horizontal arrow pointing left at south pole and one horizontal arrow pointing right on the north pole and arrows parallel to the field lines. I hope I have told you the same thing. Okay, then what they ask. Describe and explain what happens to the bar magnet when the electromagnet is switched on. So what will happen to this bar magnet? You see, so because it is expressing a force in this direction, here the bar magnet is pivoted. So here a anti-clockwise moment will be induced. Here due to the force on the S, force in this direction will create a anti-clockwise moment. So here anti-clockwise moment is produced, here anti-clockwise moment is produced. So what will happen? This bar magnet will rotate anti-clockwise. And when this north will come here and this south will be here, then it will stop rotating. When this north will rotate and come here, and the south will be here, so it will rotate anti-clockwise. And when the north and the south of these bar magnets, the bar magnet will be aligned with the magnetic lines, it will no more rotate. This is what I think. It will rotate anti-clockwise due to the moment provided by the forces. When it becomes parallel to the magnetic field lines, it will stop. So it's a 3 marks question. Let's see what the marking scheme says. It's a forces produce moment, turning effect, couple or torque. Magnet, it rotates until it is finishes parallel to the field line horizontal and anti-clockwise. So basically what I am saying is that this is going to rotate. You see, this will expressing a force in this direction. It is experiencing a force in this direction. Okay. So what will happen? This will rotate. And when this north will be here, okay, when this power magnet will become, it will become here. Draw. When the north will be here, the south will be here. Will stop rotating. Understand? This is what I was saying. Okay. So let's go to the next question. Question number coming up on your screen is question number 7. A filament lamp connected to a 12-volt power supply transfers 24 watt of power. Calculate the current in the lamp. You know the power is equals to IV. The power is equals to IV. Power is equals to the IV. So I can very easily find out what is the So here we go. So you can see that the power is equals to IV. The power is 24 watt. The volt is 12 volt. And I will be equals to the P divided by V, 24 divided by 12. That is 2 ampere. So we think that the current will be 2 amperes. The current will be 2 ampere. This is question number 7 and it's A part. The answer is 2 ampere. Our answer is right. Okay, then he says the resistance of the lamp in this circuit. Okay, so I know the voltage, I know the current, so I can find out the resistance. So R is equal, the V is equals to IR, V is equals to IR, V is equals to IR. So very easily we can find the resistance of that lamp. V is equals to IR, so R will be equals to V divided by I. So 12 divided by 2, that is 6 ohm. 6 ohm. Yes, the answer is right. Okay. Okay, so we are going to the next part. He says, so this is question number 7B part. A student has a battery of electromotive force 12 volt. The student uses the battery in a circuit with the 12-volt filament lamp to obtain a range of suitable readings and plots the current voltage graph for the lamp. The figure 7.1 shows the battery and the filament lamp. Okay. So on the figure 7.1, complete the circuit diagram of a suitable circuit. You will need to add additional apparatus. So you can connect them. You can connect different things in it. If, for example, you can connect them with the variable resistor, and you can connect an ammeter, which will be the parallel, which is in series with the lamp, and you can put there a voltmeter. So that voltmeter is always parallel to that appliance across which you want to find out the voltage drop. So the voltmeter will be parallel to the lamp. Then we have put a ammeter, and we have also put a variable resistor rheostat here. The variable resistor, we can change the resistance of that variable resistor, and the reading on the voltmeter and the ammeter will gradually change, and we can get different values of the voltage drop and the current through the lamp, and we can find out its resistance. Then he says, Okay, he says on the figure 7.2, draw the shape of the current voltage graph for the filament lamp. You see, very important. The current is here, the voltage is here. So the gradient of this graph is equals to the resistance. The gradient of this graph uh, is equals to the, sorry, the gradient of this graph is equal to the reciprocal of the resistance. So your graph should be like this. Its gradient is gradually decreasing, and which means the reciprocal is happening to the resistance of that filament lamp. As you are increasing the voltage, the current is increasing, but the rate of increase has decreased. So the filament lamp, its current and voltage graph will be like this. Here, the gradient of this graph is equals to the 1 by R. Because you see the gradient is decreasing, it means the resistance is increasing. Okay, curved line with the gradient greater than 0 starting at the origin, the curve of decreasing gradient and gradient always positive. Resistance. Okay, that's the next part. Their question is, if the question state what happens to the resistance of a filament lamp as the applied voltage increases, and explain one reason for this happening. You see, as you increase the voltage across a filament lamp, the resistance of the filament lamp increases. That's why the shape. The reason is that the temperature increases. When more and more voltage is provided to a filament lamp, its temperature increases. That's why its resistance also increases. He says the resistance increases, temperature increases, filament lamp gets hot, or particles, ions vibrate more vigorously and impede electron flow. So on your screen, the question number, your question is showing up, question number 8. So we will take a break and then I will continue. So I am back. Okay. So the question number 8, we are doing the nuclide notation for the radioactive isotope hydrogen 3 is hydrogen 1, 3. This is the proton number. This is the nucleon number. Explain why the hydrogen 3 cannot decay by the emission of the alpha particles. You know, the alpha particle, its proton number is 2 and its nucleon number is 4. So it does this particle does not have 2 protons to give away and 2 neutrons to give away. So it cannot emit alpha particle. Alpha particle has 2 protons and 2 neutrons in it. Alpha particle contains 2 protons, 2 neutrons. The hydrogen 3 only has 1 proton. So it will not be able to emit the alpha particle. So the marking scheme is showing up on your screen. You can have a look at the marking scheme as well. Question number 8, it's a B part. Hydrogen 3 decays by the emission of the beta particles to an isotope of a different element. This element is represented by the equation by Q. Complete the nuclide equation for the decay of the hydrogen 3. You see the beta particles proton number is -1 and its mass number is 0. So this the daughter cell which is produced by the emission of the beta particles, that daughter nuclear atom will have a proton number 2 and its mass number will remain same. That will be 3. Basically what happens, a neutron breaks and gives out an electron and converts into a proton. So the proton number becomes 2 and the nucleon number remains the same. So we will write it like this. Beta particle is -1, 0, and the daughter atom Q will be, its proton number will be 2 and its nucleon number will be 3. So have a look at the marking scheme. Let's check the marking scheme. 3 and 2 is the the right answer, sir. So state the name of the element represented by the Q, the proton number 2. The proton number 2 is helium. Helium has the proton number 2. Okay. So question number 8, it's C part. The half-life of hydrogen 3 is 12 years. Define a half-life. The definition of the half-life is the average time duration in which half of a given sample of an isotope will decay. The average time taken for half of the nuclei of a radioactive sample decays. This is the average time duration in which half of the nuclei of a radioisotope decays per sample, okay? So have a look at the marking scheme, time taken for something to have, time taken for number of atoms or corrected count rate to have. A sample of hydrogen-3 is placed on a laboratory bench next to a Geiger-Müller tube, GM tube, and the count rate is recorded at the at the same time on 4 successive days. Table 8.3 shows the count rates obtained. On first day it's 98, on second day it's 89, on third day it's 93, and on the fourth day it is 85. State why the count rate decreases and increases. This very simple reason is that because you have done this observation on a duration of 4 days, whereas the half-life of this isotope is 12 years. So that 4 days is a very short time for this. So this up and down is not due to the decay because the half-life is very long. This is simply because the radioactive decay, the radiation is a random process. So its values are all the time fluctuating. This is because the radiation is a random process. Radioactive decay is a random, it's a random process. Due to spontaneous or random nature of the decay. That's what the marking scheme is saying. Question number 9. A stable star in a distant galaxy has a mass that is more than 15 times the mass of the sun. State the name of the nuclear reaction that occurs at the center of the star and describe this nuclear reaction. At the center of the star, the fusion is taking place. So the smaller nuclei, like the hydrogen and hydrogen, they come close to each other due to the gravity and very high kinetic energy. They fuse into each other. The nuclei of those hydrogen atoms, they fuse into each other and they convert into the helium and they give out enormous amount of energy. This process is called the fusion, and this is happening at the core of the stars. So this is what, let's see what Hajra has written. Fusion, 2 hydrogen nuclei fuse together to form a helium nucleus at high temperature. This gives out enormous. You can write the equation also, hydrogen plus hydrogen is equals to helium. And he says 1 mark is for telling that it's a nuclear fusion. 1 mark is for saying that the hydrogen nuclei join or fuse together. And 1 mark is to tell that the helium nuclei is produced. You can also write the equation of that process. Okay, question number 9 is A, and second part, explain how this nuclear reaction helps to keep the star stable. You see, in the star, at the core, there is enormous amount of gravity. Due to the gravity, we have an inward force. That gravity is trying to collapse that star. That force due to the gravity is inward. And you know, when the fusion is happening, so the fusion is producing a force in the outward direction. So the fusion, and the heat, the energy which is produced by the fusion reaction, that is producing a force in the outward direction. And the gravity, the pull of the gravity is producing a force which is inward. So that outward and inward force, when they are balanced with each other, the star is stable. Let's see what the Hajra has written. Inward gravitational pull or force is balanced by the outward pressure exerted by the thermal energy produced by the fusion. Okay, so they say these are three marks. Reaction is transfer energy thermally. High temperature produces high pressure. Outward force. Inward force is a gravitational force balanced or further gravitational collapse prevented. Hmm. So you can write a good answer from after reading the marking scheme, after listening to our discussion, and after reading the Hajra's answer as well. Um, as a massive star approaches the end of its life, it stops being stable and becomes a red supergiant. State why the nuclear reaction can no longer keep the star stable. When you see when this red supergiant, actually what happens, the fuel has been exhausted. And the fuel is hydrogen. The hydrogen is fusing with the hydrogen and making helium. The process of fusion is taking place. So when all the hydrogen is used up, when all the hydrogen has exhausted, then this converts into red supergiant. All hydrogen has run out or finished. And then you see what happens then? Then let me read from here. Not enough hydrogen left to or run out of the hydrogen. Okay, so then the question is, describe what happens to the red supergiant. You know, you should remember the life cycle of a large star. You see what happens that when the red supergiant happens, then the fusion of the helium and helium stars, and then it explodes with a supernova. And when the supernova happens, then the core of that very large star that either converts into a neutron star or it becomes a black hole. If that star is very large, it will convert into the black hole at the end. He says any three from red supergiant explodes, turns into a supernova, produces heavy elements, forms a nebula. When it explodes, it forms a nebula and leaves behind the core becomes a neutron star, or it will convert into a black hole. It's a 3 marks question. Please read it from your notes and then write this answer. Oh my God, we have reached the end of this paper. So, my dear students, we are done with this paper. In this video, I have presented you the solution of this paper. And at the end of this video, also, I want to thanks again the Cambridge Assessment International Education, CAIE, because the papers and the marking schemes which we have used in this paper, I have downloaded from their website. These papers and the marking schemes, they are the property of the Cambridge. These papers and the marking schemes have not been created by me. In this video, I have only written the solution. The solution was also written by one of my students. And I have only tried to describe you how to write the solution. So all the credit is to the Cambridge and to Aja. She wrote the answers. I have only described the solution. The papers, the marking scheme, they are the property of the CAIE. If you think this video is useful, if you think this video is interesting, if you think that this video can be helpful to your teacher, to your junior students, to your senior students, please share the link of this video with them. You see, share the link of this video on WhatsApp, on your Facebook, on your TikTok, on your Instagram, on your Snapchat, wherever, on your X, on your LinkedIn. When you paste the link of this video on your social media, you see my channel gets more and more traffic. This is a kind of support to my work. If you will support me, I will be able to continue this work and I will be able to make more and more videos on the past paper solution. Thank you very much for watching this video and preparing your exams from my channel. It's a great blessing for me. Thank you very much, everyone. Have a good day. God bless you all.